In this video, I'm going to go through number patterns for grade 11. So let's jump right into it. So linear number patterns. A linear number pattern is also called an arithmetic pattern. So this is a keyword that they might use within a sentence. So linear means arithmetic. And they're called linear because the same value is added or subtracted to get to the next term. So for example, 2, 5, 8, 11, you can see that to get from 2 to 5, you're adding 3, from 5 to 8, you're adding 3, etc. So another way to think of this is that you're taking the second term minusing the term before it, the first term. So 5 minus 2 is 3. So this can be done along the whole number pattern, taking the bigger term minus the term just before it, and you will get that same difference. So we call it a constant difference. Mathematically, you can represent this using this little equation. Term 2 minus term 1 is equal to term 3 minus term 2. And this is very important to remember for the higher order questions, which we will go through. In grade 11, we use a formula to find the general formula for linear patterns, as well as the other patterns. This formula is Tn equals a plus n minus 1d. Your a value is your first term. Your n value is the value of the term that you're working with, the term number. Generally, in the general formula, we don't substitute for n. And d is your constant difference between the terms. So let's do an example. Find the general term Tn of the pattern. So if you get asked for the general term or the Tn of the pattern, they're just wanting you to solve the general term. First step, I would always write out the general formula. Tn equals a plus n minus 1d. This d value can be put in front of the bracket if you like. I'm just used to putting it at the back of the bracket, but you're ultimately multiplying that d value into the bracket in the question. So the a value here corresponds to our first term, which is 2. To get from 2 to 5, or from 5 to 8, we can do a little sum. 5 minus 2 is equal to 3, and 8 minus 5 is equal to 3. So our d value is equal to 3. We're adding 3 each time to get to the next term. Now we can substitute in our a and our d value. So Tn is equal to 2 plus n minus 1. Our d value is 3. Now in our next step, we're multiplying this 3 in. So Tn is equal to 2 plus 3n minus 3. Our final step is to just simplify. 3n, 2 minus 3 is minus 1. That's our general formula. And we can check ourselves, if you want to, by substituting in a term number, and we should get the corresponding value. So let's substitute in 4, and we should get 11. So T4 is equal to 3 times 4 minus 1. 3 times 4 is 12, minus 1, we get 11. So we know that our general formula is working. Question B, find the general term as well as term 50. So here we go, what are we adding each time? We know that it's linear, so we are adding or subtracting the same value each time. So let's see, T2 minus T1, which is minus 6 minus 3. Remember that bracket. So it's minus 6 plus 3, which is minus 3. And the same thing happens for minus 6. We are minusing 3 to get to the next term. So our constant difference is 3. So minus 3. And our a is also minus 3, our first term. Tn is equal to a plus n minus 1d, minus 3 plus n minus 1 times minus 3, minus 3 minus 3n plus 3. The 3's cancel, the negative 3 and the positive 3, so we're left with 3n. So Tn is equal to 3n. Okay, term 50, T50 equals minus 3 times 50, which is equal to minus 150, minus 150. Okay. Find the general term of the pattern and which term equals 152. So question I, 12, 19, 26. What do we need to do? 19 minus 12, 7. And we're hoping to see a 7 with 26 minus 19, which we do. So our D is 7 and our A is 12. Tn equals A plus n minus 1d. A is equal to 12. D is equal to 7. And we simplify. 12 plus 7n minus 7. 7n, 12 minus 7 is 5. That's our general term. Our next question is, which term equals 152? So 152, see this is which term equals, so we're solving for an n value. So 152 is equal to 7n plus 5. We take the 5 over, so we're left with 147 is equal to 7n. Divide both sides by 7 to isolate n. N is equal to 21. That's the question done. Then a more challenging question is if they don't give you the actual value of the terms, but rather they give it to you as expressions. So in this example, a plus 2, 4a, and 6a plus 4 form an arithmetic sequence. So that's telling us that it's forming a linear pattern. Calculate the value of a and determine the actual value of the first three terms. This is where your theory comes in very important. The difference value is T2 minus T1 is equal to T3 minus T2. Now we can use algebra. So let's sub in. T2 is 4a minus T1 in a bracket, which is a plus 2, is equal to T3, which is 6a plus 4 minus 4a. And let's simplify. 4a minus a minus 2 is equal to 6a plus 4 minus 4a. So 3a minus 2 is equal to 2a plus 4. Let's take the a's to the left. So 3a minus 2a is just a. And 4 plus 2 is 6. So your a value is actually 6. So then to get the different terms, the actual values, the first one is a plus 2. So 6 plus 2, which is 8. 4 times a, which is 24. And 6 times 6, which is 36, plus 4, which is 40. So there's your first three terms. Okay. You can pause the video here to do this question. A linear number pattern with a constant difference can be represented by those terms. Determine the numerical value of x and the numerical value of the third term. You follow the same steps. I will give the answer. X should come to 2. And the third term, you should get a value of 11. So you can pause the video and try that example. Next, I'm going to go through quadratic number patterns. So this is introduced in grade 11. Quadratic number patterns have a constant second line of difference, and it forms the quadratic formula. Tn, instead of x's, we use n's. Tn is equal to an squared plus bn plus c. This should be familiar from your algebra section. And we can calculate the a, the b, and the c value by using these shortcut formulas. And you can see it in my diagram. 2a will equal the second line of difference value. Quadratic number patterns, as I've said, have a constant second line of difference. So in the diagram, you can see that our terms are 7, 19, 37, and 61. When you minus 7 from 19, you get 12. 37 minus 19 is 18. 61 minus 37 is 24. But then you can minus the difference between that first line of difference. And you get 6. 18 minus 12 is 6, and 24 minus 18 is 6. So that's a second line of difference, and it's constant. We get 6 both times. This is how we know it's a quadratic pattern, because it has the second line of difference, which is the same value. It's constant. So we can make 2a equal to that value. So 2a is equal to 6. Then for the next formula, we can make 3a plus b equal to the first value of the first line of difference. So 3a plus b is equal to 12. Okay. The next one is a plus b plus c equals the first term. A plus b plus c is equal to 7. And we then solve from top to bottom. So 2a is equal to 6, so a is equal to 3. Then we can sub in that a value in our next formula. So 3 times 3 plus b is equal to 12. So b is equal to 12 minus 9, which is 3. Then we can substitute our a and our b in this next formula. So 3 plus 3 plus c is equal to 7. So that means c is 7 minus 6, which is 1. So Tn is equal to 3n squared, our a value, plus 3n, our b value, plus 1, our c value. So now we've solved for a, b, and c, and we have our general formula. So you have to just memorize those shortcut formulas. They will not be given to you in a test. So you have to memorize 2a is the second line of difference value, 3a plus b equals the first value of the first line of difference, and a plus b plus c is the first actual term. And then you just solve. Okay, so you can see that here in this diagram below. 2a is equal to 6, 3a plus b is 12, a plus b plus c is 7. And you can even ring those if you want in the test. And then you can write the algebraic expressions out somewhere else. And then you just have to summarize your answer by subbing in the a, the b, and the c into the quadratic formula. So let's do some practice examples. Determine the general term of the following pattern and T10. So in a test situation, they might not tell you if it's linear or quadratic or geometric. You have to assess. So let's see. 11 minus 2 is 9. 21 minus 11 is 10. And 32 minus 21 is 11. So that's not constant. So we can do it again. And 10 minus 9 is 1. And likewise for the next one. So I can see that this is quadratic because there's a constant second line of difference. So 2a is equal to 1. 3a plus b is equal to 9. And a plus b plus c is equal to 2. So 2a is equal to 1, a is equal to a half. Then 3 times a half plus b is equal to 9. So that means that b is equal to 15 over 2. That's something you can do on your calculator. And then a plus b plus c, which is 9 plus 15 over 2 plus c is equal to 2. C will come to minus 6. So Tn is equal to half n squared plus 15 over 2n minus 6. That's your general formula. To get T10, you just sub in a 10 in a bracket. A half 10 squared plus 15 over 2 times 10 minus 6. And you can do that on your calculator. And you should get an answer of 119. Okay, let's do one more example. Given the sequence 3, 9, 17, 27, write down the value of the next term in the sequence. So we can then see here, look at question 2 to make this easier. Determine an expression for the nth term. So they want the general term. So I'm going to start the work here and work backwards to get that next term. 9 minus 3 is 6. 17 minus 9 is 8. 27 minus 17 is 10. That's not constant, so we're hoping that this will be 8 minus 6 is 2. 10 minus 8 is 2, so that's constant. So in order to get the next two terms, I know that I'm going to be plussing 12 here. So 27 plus 12 is 39. And I'll be plussing 14 here. So 39 plus 14 is 53. So those are our next two terms. 39. Oh, we just needed one term. So the next term is 39. Okay, so determine the nth term. So now we're working out the general formula. So 2a is equal to 2. 3a plus b is equal to 6. So this will always be, these three formulas will always stay the same. A plus b plus c is equal to 3. So 2a is equal to 2. So a is equal to 1. A plus 3a, which is 3, plus b is equal to 6. So b is equal to 3. Then a plus b plus c. So 1 plus 3 is 4. Plus c is equal to 3. So c is equal to minus 1. So Tn is equal to n squared plus 3n minus 1. And that's our general term. Then calculate the value of the first term that is greater than 269. So we can set up an inequality. So 269 is less than n squared plus 3n minus 1. We can then take over that 269, so it becomes minus 270. And then we can put this into a bracket because we can do our factors using your quadratic formula or any other method. And you should get these two factors. So this is now an inequality. Our critical values are 15 and minus 18. And we can plot this on a number line, minus 18 and 15. And we're looking for values that are greater than. So everything that's above the x-axis, because it needs to be greater than a y value of 0. Because we're working with term numbers, we don't care about negative solutions because it doesn't make sense to say a solution is negative. So from 15 onwards is going to give us term values greater than 269, but they want that first term. So the 15th term won't do it, but the 16th term will. So T16 is equal to, and you can sub in 16 then into n's place, and you should get 303. And you can double check yourself. You can substitute in a value of 15 for n, and you'll see that term 15 actually comes to 269. So that's not the first term that's greater than 269 because it's equal to. It's term 16, which is 303. So there are more challenging type questions, but I will leave it at here because these are the most important basics for number patterns, and I hope that this video has helped.